So we're going to start 8.3. So this is our estimation of mean when sigma is unknown. So this is when we do not know the population standard deviation. Okay, so that is your difference. And we're going to make a chart to go over the differences between the two. But when we do not know, so when the population is approximately normal and the population standard deviation is not known, then we're going to use a t distribution. There is one parameter in the t distribution which has to do with the sample size, and that is called the degrees of freedom. Okay, so df, totally dependent on the sample size. Degrees of freedom is the sample size minus 1, so n minus 1. When we are constructing a confidence interval, it is the same formula as what we did in 8.2, except instead of z, we're using a t. So it's going to be the mean plus or minus t times the standard deviation of the sample, which is the standard deviation over the square root of the sample size. So the only difference is you're using a t value instead of a z value. So for example 5, we have a sample size of 25, an x bar of 186, a standard deviation of 12, and a 95% confidence interval. We want to construct the confidence interval for the mean. So notice here that the standard deviation that's given is S, which is a sample standard deviation. Remember, population standard deviation is sigma. So that's population. S is your sample. So it's telling you this is a sample standard deviation, which means you use T. We're using T because it's in this section, but once you get to the chapter 8 quiz, it's not going to tell you which section this is. So you have to determine it. So the first thing that we would do for the confidence interval here is you're going to find the standard deviation of the sample, which is going to be, we're going to use the sample standard deviation S, so 12, over the square root of the sample size, which is 25. So there you have 12 over 25, which is 12 divided by 5, which is going to be 2.4. Okay, so my standard deviation of my sample is 2.4. Next, you're going to find T for the sample. So the first thing you're going to do is find the degrees of freedom. Okay, so the degrees of freedom is n minus 1. So that is going to be 25 minus 1. So 24 degrees of freedom. Okay, so to find the area in each tail, that's the next part. So go back up to your confidence level, 95%. So the area in each tail is going to be, remember, 1 minus 0.95. So that's 0.05, and then divided by 2, because you want 1 on each side. So 0.05 divided by 2 is going to give you 0.025. And then you're going to go to your t-table. Okay, so you have 24 degrees of freedom and a 0.025 in your tail. So area in the right, so you're just looking at one side of the tail, so 0.025. And then you're going to go down the degrees of freedom until you get to 24. So that is going to be right here, 2.064. Okay, so we are going to use 2.064. And remember, when you split it into the two sides, you're going to have the negative and the positive on either side. So it's plus or minus 2.064. Okay, so then we use the formula to find the margin of error. So remember, the formula is going to be T times the standard deviation of your sample. So our T is 2.064, and the standard deviation we found up here was 2.4. So let's see, 2.064 times 2.4. Whoops, what did I write in there? 2.64 times 2.4, 4.9536. Okay, so then finally the confidence interval, X bar, which is given to us as 186, plus or minus the margin of error, 4.9536. Okay, so 186 plus 4.9536 gives us 190.9536, and 186 minus 4.9536 gives us 181.0464. So the interval here, 181.0464, and then 190.9536. And then depending on how many decimal places you're asked to round, you would round from there. All right, so same process as what we did in 8.2. It's a longer process, okay, but this time we're using the t-table. And you can do this in your calculator. So let's check this in our calculator. Okay, so in our calculator, we're going to go to the button that says Stat, and then you're going to go over to Tests. Okay, just like we did for Z interval, but now you're going to T interval. So that should be right underneath Z interval. Okay, then you're going to press Enter, and then make sure Stats is highlighted. So Data is highlighted, go over to the right, Stats. Okay, and then you're going to put your stats in. So our X bar is 186. Okay, our standard deviation of our sample size is 2.4. So you do need to actually put that calculation in, 2.4. I think so. Actually, let's just check, make sure. Then the sample size, 25. And the confidence level was 95%. So then we're going to hit calculate. This takes a little bit longer because it has to look up the t-values. Okay, that's off because, so you don't have to do this calculation. I'm just kidding when I said that. So let's redo this. Stat, tests, t interval. So the sample, you don't have to do the calculation. You just put it in as 12. It will do it for us. That should correct this. There we go. Yes, so 181.05, 190.95. So this is only going to round to 2 decimal places for you guys. So if you're asked to round further than that, you're going to want to do it by hand. Okay, now the calculator, especially when we get into the larger t-values, the calculator is going to be more accurate because if you look at this chart, this only goes up to a sample of 75, and then anything above 75, you're asked to use the bottom row for an infinite number of values. But let's say your sample size is 78. Okay, it's going to be slightly off by a few decimal places. So you do need to be able to do this in your calculator to have the more accurate values. Now that being said, on the test, it's not gonna be like one question is with the infinity values and one question's with the calculator. It's going to be close enough so that you can find the correct answer. All right, so now let's do the same data with a 99% confidence interval. We're going to do it in our calculator. Okay, so, well, actually, we'll do both. So the standard deviation of X bar, remember, was 12 over the square root of 25, so that was our 2.4. Our t, we've got to find our t now, and then we'll do the margin of error. So the t for 99% confidence interval, to find that value, okay, to find t, okay, we're going to go 1 minus our confidence value, 0.99. That's going to give us 0.01, and then we're going to divide it by 2. So that's going to give us 0.005. We're going to take that, we're going to look that up in the t-table with the degrees of freedom, n minus 1. So 25 minus 1, 24. So I go to this t value and I go to degrees of freedom 24. And then let's see, 0.005, that's over here. So this 1, 2, 3, fifth value, fifth row, 24, that's going to be 2.797. Okay, then our margin of error is going to be t times standard deviation of x. So 2.797 times 2.4. So that's going to be 6.7128. And then the confidence interval is going to be x bar plus or minus e. So our x bar was 186 minus 6.7128 and then plus. So there you're going to get 179.2872. We'll do 2 decimal places. So 179.29, 192.71. And then let's go ahead and check it in our calculator. So go to Stat, over to Tests, then go down to T interval. Stats is highlighted, X bar is 186, standard deviation of the sample is 12. My sample size is 95. My confidence level has changed to 99, so 0.99. Calculate. And there we go, 179.29, 192.71.